Hello everybody, getting ready to do lesson 1.1 part 2 of pre-calculus math today, lines in a plane. This is my email for course materials and tutoring or any other things you need to get a hold of me for. Teachers, email me here for materials. 1.1 lines in a plane part 2. Today you have 4 points in your notebook taking. And then you have 36 points here on your classwork sheet, students. So have your classwork sheets ready. First, we're going to go into our bell work today. Teachers, here's today's bell work. Determine whether the expression is a polynomial. If it is, write the polynomial in standard form, students. So you have this here. Give your students 4 minutes for this one. Okay, welcome back for the answers of today's bell work. For the number 1 up here, no, the term x to the negative 1 is meaning it's the reciprocal of x, causes the expression to not be a polynomial, no polynomial. And then this one, nope, because this whole quantity here is to the 1/2 power. So neither one of them are polynomial, students. Hopefully you got that. Okay, page 1, classwork. Students, have your classwork sheet ready here. Library of parent functions, linear function. In the next section, you will be introduced to the precise meaning of the term function. The simplest type of function is the parent linear function, f of x equals x. As its name implies, the graph of the parent linear function is a line. Here is f of x equals x here. This goes in your notebook, students, page 2. The function f of x equals x is also referred to as the identity function. Later in this course, you'll learn that the graph of the linear function f of x equals mx plus b is a line with a slope m and y-intercept 0b. So here's your slope here, and then here's your y-intercept there. When m equals 0, f of x equals b is called a constant function, and its graph would be a horizontal line. And y equals b would be a horizontal line. So sketching graphs of lines. So many problems in coordinate geometry can be classified as follows. Number 1, given a graph or parts of it, find its equation. Number 2, given an equation, sketch its graph. So when we have those two conditional situations, notebook page 3, for lines, the first problem is solved easily by using the point-slope form. This formula, however, is not particularly useful for solving the second type of problem. The form that is better suited to graphing linear equations is the slope-intercept form. This is the big daddy of writing equations, the slope-intercept, and it's y equals mx plus b. And slope-intercept form of the equation of line, the graph of the equation y equals mx plus b is a line whose slope is m. Here's your slope, here is m, and then b is your y-intercept. So let's try one here. Example 4, using the slope-intercept form. Just determine the slope and y-intercept of each linear equation, then describe its graph. Here we have this. We need to put it into slope-intercept form. So to do that, there's the original, and then we move our x over here. So y equals 2 minus x. Then we have y equals negative x plus 2. This is slope-intercept form here. So what would be your slope here? From the slope-intercept equation, the slope is negative 1, and the y-intercept is 2. So you have a situation, here's your line here for that. Here's your y-intercept here, and the line has a slope of negative 1. So y equals negative x plus 2. This is what that line would look like. Because the slope is negative, you know, the graph of the equation is a line that follows 1 unit for every unit it moves to the right. So from left to right, it follows 1 to 1. Okay, y equals 2. What would that look like? By writing the equation y equals 2 in slope-intercept form, you know that it would be a horizontal line, y equals 2. You have a slope of 0. Horizontal lines have slopes of 0, but your y-intercept is 2. You know that much. You can see the slope of 0, y-intercept is 2. So zero slope implies that the line is horizontal. Okay, let's go into our guided practice here. Determine the slope and y-intercept, if possible, of the linear equation that describes graph. So the first step here is to solve for y. So slope is 1/2. We put this in slope-intercept form. We solve for y here. We have 1fx minus 2. There's our slope there. And then our intercept is -2. Line passes through 0, -2. So meaning that it rises 1 unit for each horizontal increase of 2 units. So down here, solve for y. Put it in slope-intercept, -3/4 plus 1/4. So the y-intercept is 1/4, and so 0, 1/4, and it falls 3 units for each unit increase of 4 units. It falls 3 units for each horizontal increase of 4. I don't know about that, but anyway, it has a slope. Oh yeah, here's your slope here. Yeah, that would be right there. I was looking at the slope-intercept. Or rather at the y-intercept, sorry. From the slope-intercept form of the equation of a line, you can see that the horizontal line m equals 0 has in the equation of the form y equals b. And this is consistent with the fact, and this is your classwork, page 7, that each point on a horizontal line through 0b has a y-coordinate of b. Similarly, each point on a vertical line, a0, has an x-coordinate of a. So a vertical line has the equation of 4x equals a. That'd be a vertical line. This equation cannot be written in slope-intercept form because the slope of a vertical line is undefined. However, every line has an equation that can be written in general form. Ax plus by plus c equals 0. General form of the equation of a line where a and b are not both 0. Summary now. Summary of equations of lines. Here's a great summary here for the equations of lines. Students, get this down. General form, vertical line, horizontal line, slope-intercept form, and point-slope form here. Okay, let's go into another example. Example 5. Different viewing windows on your calculator. When a graphing calculator is used to graph line, it is important to realize that the graph of the line may not visually appear to have the slope indicated by its equation. This occurs because of the viewing window used for the graph. Say, for instance, y equals 2x plus 1, produced a graphing utility using 3 different viewing windows. So notice that the slopes do not visually appear to be equal to 2. So this here, 2x plus 1, does that look like a slope of 2? Well, yeah. Does that look like a slope of 2? No, it doesn't at all. But they have a y-intercept here, both of 1. So why is that? This has a res here of 10. This has a resolution of 3. So when you shrink it like this, it distorts the graph. This has a y has a max of 10, min of 10. And then same thing here, but your x maxes and x mins are square. That's what makes it look more realistic here. So using a square setting, you can obtain a graph with a true geometric perspective. And this is like 15 here and 10, so you come out 15, and it makes it appear steeper now. Then this here is more authentic. Okay, let's try one. So 0.5x minus 3. So describe the differences of the graph. So we have these settings here for this function here. Which one is going to make it look more authentic on your graphing calculator? So the first graph does not show both intercepts. This one here won't show both intercepts. So you have something like this. It's focused in because your y-min here is -1. So you won't really get in your y-intercept here because it cuts it off. And then over here, yeah, you'll get in your y-intercept here. Your y-intercept is down there. And then your x-intercept is up here. That one looks pretty good. That would be acceptable to me. The third graph is the best. They say this is the best because you get more of a perspective over here, it pulls that in more. And that was 1.1 part 2 of your pre-calculus math today, plotting, making graphs. And email me here for course materials and questions. Thank you.